with exercise 2, and our video has been made to show us just a quick recap. Coefficient is the value, the variable is the letter that changes, the constant is the fixed numerical value. Also remember that the signs attached to certain values count, okay? Because a minus 2x is not the same as a positive 2x. So in example 2, in which I've made the video, your links all posted already. You can try these 2 links. When we see that I explain it on those links, I'm trying to show you how to become comfortable with the idea of playing around with an unknown. So let me just use y, because I did not discuss y here on the board. Then, I. Then I ask myself y take away 2 should give me 7. Because this is by inspection, we don't have to calculate as such, but we can consider a value, subtract 2, and the result is 7. Considering that value, the inverse operation will allow me to take it from the right-hand side, saying if I'm left with 7 and I had 2 more, then the answer should be 9. Therefore, y is equal to 9, because 9 minus 2 is then equal to 7. So therefore, y is 9. Now, I highlighted these ones in blue, where I just wanted you to watch out for either the division or a power of x. And when we work with the power of x, it is important that we also change our concept of 2 times 2 to 2 to the power of 2. 2 times 3 is not the same as 2 to the power of 3. So what I did is I did a little summary there just to get back to that. And for this one, number P, I asked myself the square root of something should give me 9. And I found that the square root of 89 should give me 9. Therefore, x is 81. So the square root of 81 gives me 9. Now, just to try and prepare you comfortably for what is coming up, I want to just give you a hint as to how to approach your equations, which will be explained in example 2 and examples prior to exercise 3. The instruction says to solve. Says to solve the following equations by adding and subtracting, multiplying or dividing both sides of the equation by a constant. Now, all of that's been said right there in a nutshell. All of this actually means by balancing your equation. And what do we have to do then? We have to check our answers. So when you run through your memos and eventually mark your work, you're going to see that there is an addition there, not just a solution for x, but also a check system, where we then check whether that value that we found for x is in fact correct. So we start with number 1, and we are asked x plus 6 equals 9. And my main concern is to keep my equal sign always directly under each other, so that I can separate the left-hand side from the right-hand side. Now, the concept here is to apply an inverse operation in order to isolate x. We want x to stand on its own at the end of our solution. Therefore, my x will preferably remain on the left-hand side. And I will see I have a plus 6. And here I have equal to a positive 9. But I want to undo plus 6. So I'm going to undo it by taking away 6. But because it's a scale, what I do on my left-hand side, I have to do on my right-hand side, and that I manipulate equally on both sides by applying -6 on both sides. This allows me then to see that +6 minus 6 leaves me with 0. And I have x. Nothing is now affecting x anymore, but what do I get from 9 minus 6? The answer is 3. And you may start using your therefore sign in your margin, not an equal sign, please, because you cannot have equals here and equals there. That will be incorrect. So what we want is we want a therefore sign, and we find ourselves with a positive x. X is positive, it's only 1x. There's a little positive 1 there. What is my coefficient of x? Coefficient may not contain x or x squared or x cubed. The coefficient here is just a positive little 1. But now I can see, great, I've done my work. X is 3. But then we are required to check our answer, which means I go back to my original equation. I go back to what was given. X plus 3 is x plus 6 is equal to 9. I rewrite it, and now I take that value that I got for x, and as in exercise 12 with our previous chapter, I substitute it into my equation, and I see, what do I get? I get 9 is equal to 9. Therefore, well done, I'm happy because left-hand side is equal to right-hand side. That is your checking process. And the number of steps will depend on your understanding of how to eliminate or get rid of any constants. Now, what I did here in the highlighted blue is I added, or I might subtract or divide or times, multiply by a constant. What is a constant? A constant is that numerical value that remains the same at all times, no change. Right, so what we see now at number 2, the equation is given x minus 6 is equal to 9. I'm going to first write down my equal sign so that I know I need to work in a good order, and then I'm going to keep my x that's here, my minus 6, leave a little gap, 9, leave a little gap. Think to myself, how can I get rid of minus 6? I add 6. What I do to this side, I must do to the right-hand side. And I find, therefore, that x plus 0, this gives me 0, is equal to 9 plus 6, which is 15. Therefore, x is equal to 15. And like I said, later on, we don't have to still write this step in, for example. Later on, we may go straight to that step. We may even go straight to just x is equal to that and therefore that, but it will come in the near future. Now we need to check, and to check means to check that the left-hand side will be equal to the right-hand side. That's how you are going to check. How do I check? I insert and substitute my new value that I found. I go back to my original equation, which was x minus 6 is 9, and I substitute my newly found value into the position of x. I keep the equation as it is. The integrity of the equation must remain. Do I get 9? Yes, I do. Left-hand side is therefore equal to my right hand side. And this is how you can actually guarantee that you'll get 100% for this section in maths. Now, let me do number 6, for example. Number 6, slightly more complicated because we have positives and negatives. And we need to also work very accurately with those signs. So, n minus 2 equals minus 5. Okay, right. I've got to really just take a step back. First, let's align our equal sign. Why am I doing this? Because if this is clear, my brain will see what am I doing on the left-hand side, what am I doing on the right-hand side. So we find ourselves saying, I keep n here, I move minus 2 there, and I leave a little gap. Minus 5, please don't write 5, leave a little gap, okay? I ask myself, how do I undo the minus 2? I undo the minus 2 by adding 2. What I do to that side, I do to this side. And here we have to work very carefully. We are not multiplying or dividing with positives and negative signs. We are not doing that. We are merely working on the number line. And I have to stress the importance of this because you are still getting confused. So don't let that trick you. Now we can go ahead and say minus 2 plus 2, that's 0. So it leaves me with n. And what I have on that side, minus 5 plus 2 leaves me with negative 3. Therefore, I'm done. I don't need that extra one there. Now I take my answer and I check. The original n minus 2 equals minus 5, my original equation. What am I doing? I'm busy doing the check. I plug in the value that I've found for n. I keep the original equation. I work clearly in line, and I see this. Once again, I'm going to warn you, is not minus times a minus. It is not multiplication. This is working on a number line. I have minus 2 and I minus another 2. I have minus 3 and I subtract another 2. So does that give me minus 5? Yes, it does. Therefore, minus 5 is equal to minus 5. I have balanced my equation. Therefore, my left-hand side is equal to my right-hand side. And I have 100% for my answers. So, if you can try and keep that going, you are going to be fine. I'd like you all to remember, here are the links. If you have not accessed them yet, they are on Teams. Plug them in, subscribe to my channel. You'll be notified if you have any new videos to watch. And I want you to use them for your benefit because I'm explaining how to do your work in the Mind Action series. Okay.